Hello, my dear students. In the last period, we have studied about the energy factor and orientation factor. Now, for the exothermic reaction, let us understand the formation of Hi from H2 and I2. So, you can see that this is HH, that is H2, this is II, that is I2. From this, the intermediate or activated complex is formed. So, the old bonds are broken and the new bonds are formed, and then from these old bonds are completely broken and the new bonds are fully formed, and we get the two molecules of Hi. So we can simply write it in this way, that H2 and I2, they react to give us the intermediate, and from this intermediate we get two molecules of Hi. Now we want to understand the same graphically, or we want to understand the same in the energy diagram. So please try to understand, my dear students, well. See, here you have the H2 and I2. They have some collective energy which is known as the ER, which is also the energy of the reactants. Now from outside we give some activation energy. So due to the activation energy, the activated complex is formed. This is activated complex or the intermediate, where the half bonds are broken and half bonds are formed, and from there the energy decreases and ultimately the products are formed as a 2Hi. This energy is known as the EP, that is the energy of products. Here you can see that the energy of reactant is more than the energy of products. So this delta H energy is released, that is produced during the reaction, and that is why this reaction is known as the exothermic reaction, because during this reaction energy is released. And you can see here that activation energy Ea is equal to this is your threshold energy minus energy of reactants. So these all things you can easily understand. From the graph we can understand Er, that is the energy possessed by the reactant species. Ep is equal to energy possessed by the product species. Ea is the activation energy. ETH is the threshold energy. We can see here that energy of reactant is more than the energy of product, and that is why the reaction is exothermic. That means the energy is released, means the product have less energy than the reactant, so reaction is exothermic. Delta H value is negative and delta H value is Hp minus Hr. So energy of products and energy of reactants, energy of reactant is more than energy of products, and that is why this value is negative. Energy is released during this reaction. That is what we can simply understand. Now we want to understand the same for the endothermic reaction. Endothermic reaction is the reaction in which the energy is not released but energy is required. So we can understand it from the diagram, that this is the energy of reactants. From energy of reactants, we just simply uh, provide some energy which is known as the activation energy. So from here we give the activation energy. Due to this activation energy, the energy of reactant reaches to the energy of like threshold energy, and due to that the activated complex is formed, and when from the activated complex the products are formed. Now you can see here that in these products have the higher energy than the reactants, and that is why the energy is not released, but we from outside we give this activation energy, and that is why the energy is required for this reaction to takes place only. So here we can simply say that energy of reactant is less than the energy of products, and that is why the reaction is an endothermic reaction. Here the value of delta H will be positive because the energy of product is more than the energy of reactants. Energy is not released during the reaction but consumed during this reaction. Now we want to understand the effect of catalyst on the rate of reaction. So let us try to understand the effect of catalyst on the rate of reaction. What is catalyst? Catalyst is the substance which alters the rate of reaction. Alter means changes the rate of reaction by altering the pathway of the reaction mechanism and reduces the activation energy. So these are the characteristics of the catalyst, that catalyst alter the pathway of mechanism, and it alter the pathway, or the new pathway is as such that the activation energy of the reaction has been decreased. Let us understand the same by graph. My dear students, please understand this graph so that you can understand the catalyst well. Here, my dear students, you can see the graph. Here we have taken the potential energy on the y-axis and reaction coordinates on the x-axis. This red clear line is the line or is the curve for the reaction pathway with without catalyst. So this is the way by which the catalyst, without catalyst, the reaction takes place. This is the energy of reactants, this is the energy of products. Here we can see this is the threshold energy and this is the activation energy for the reaction without catalyst. So you can see here this is the activation energy. Now what happens, we use catalyst. So with catalyst the pathway is being changed, and you can see that the activation energy with catalyst has been decreased as compared to the activation energy without catalyst. And this is how we can understand that the catalyst alters the pathway. The new pathway is as such that the activation energy has been decreased, and that is how the rate of reaction has been increased, or reaction has been made little faster. So when catalyst decreases the energy called activation energy by altering the pathway of mechanism, it increases the rate of reaction. Some other facts about this: a small amount of catalyst can catalyze large amount of reactants. Please remember, my dear students, a catalyst does not alter the Gibbs energy, that is delta G, for the reaction. Catalyst can catalyze spontaneous reaction only but cannot catalyze the non non-spontaneous reactions. Effect on equilibrium: a catalyst alter the rate of forward reaction and rate of backward reaction equally, thus it helps to attain the equilibrium faster, but catalyst does not change the equilibrium state or equilibrium constant. Some important notes: the presence of some substance during the chemical reaction decreases the rate of reaction. Such substances are called the negative catalyst or poisons. Now we will understand poison with an example. In the process of formation of ammonia, that is the Haber process, iron oxide is used as a catalyst, but the presence of carbon monoxide decreases the rate of reaction, and that is why your CO is poison for this reaction. I hope, my dear students, you are enjoying. Happy learning.